Assalamualaikum and hi, welcome to lesson 2 of tutorial 7 Trigonometric Functions. So in this video we are going to discuss question 3. If cos alpha negative 12 per 13 and sin beta 3 per 5 and both are obtuse, compute tangent alpha minus beta. First, highlight the word obtuse. What does obtuse mean? So obtuse means angle in between 90 degree and 180. So if you draw that, it is actually in the second quadrant. So we have alpha in the second quadrant and also beta in the second quadrant. So from here, you can label the value. For example, cos alpha negative 12 per 13. If you remember the SOHCAHTOA rule, SOHCAHTOA. So cos alpha is cos alpha 12 per 13. So cos in the second quadrant is negative value. So 12 is the length of the adjacent and 13 is the length of the hypotenuse part. So the adjacent part of the right angle triangle is down here, 12, and the hypotenuse part is the diagonal part, which is 13. And from there, using Pythagoras theorem, you can find the length of the other side, which is 5. Okay, so for sin beta, sin is following the rule of SOH, 3 per 5. So 3 is the length of the opposite and 5 is the length of the hypotenuse. Then you can find the length of the other side, which is 4. Okay, so let's proceed with question A, tangent alpha minus beta. So we are going to use the rule of compound angle. So tangent alpha minus tangent beta over 1 plus tangent alpha tangent beta. So let's go back to the triangle. We have cos alpha. So you need to find what is sin alpha and tangent alpha. Sin alpha is opposite over hypotenuse. So the opposite is 5. Hypotenuse is 13. So in the second quadrant, sin is positive. For tangent, opposite over adjacent, so 5 per 12. So in the second quadrant, tangent is also negative. The only positive in the second quadrant is sin. So let's find cos beta and tangent beta. So cos beta is negative 4 per 5. Tangent beta is negative 3 per 4. Now we are going to use this value to answer our question. Substitute in tangent alpha and tangent beta. So negative 5 per 12 minus negative 3 per 4. Divide by 1 plus negative 5 per 12 times negative 3 per 4. And then simplify 1 over 3 over 21 per 16 and final answer 16 per 63. Question B is sin alpha minus beta. By compound angle formula, sin alpha cos beta minus cos alpha sin beta. Substitute in the formula 5 per 13 times negative 4 per 5 minus negative 12 per 13 times 3 per 5. and then use a calculator, you will get 16 over 65. And for C, cos alpha plus beta, use compound angle formula, cos alpha cos beta minus sin alpha sin beta. Substitute the value, negative 12 per 13 times negative 4 per 5 minus 5 per 13 times 3 per 5. So you will get final answer 33 per 65. So we have done question 3. Now, your task is to do question 4 and 5. Now let's proceed to question 6. Given that sin x plus y equals to p cos x minus y, and show that this equation can derive tangent x equals p minus tangent y per 1 minus p tangent y. So we are going to use this first equation. So let's start with sin x plus y equals p cos x minus y. So this is actually in the form of compound angle. Then we can use compound angle formula. Sin x plus y is sin x cos y plus sin y cos x. And cos x minus y also by compound angle formula. Cos x cos y plus sin x sin y. Now if you see in this equation, there is no tangent x, tangent y. So in order to get tangent x and tangent y, let's look at the definition of tangent. Tangent is sine per cos. So remember, tangent x is sine x per cos x, and tangent y is sine y per cos y. So I am going to divide this equation by cos x cos y, because in that case I will get tangent. So if I divide by cos x cos y for each term, so let's say sin x cos y divide by cos x cos y, and sin y cos x divide by cos x cos y, and also for each term. And then we are going to simplify. Cos y per cos y cancel out. Cos x and cos x cancel out. And then from here, we have sin x per cos x is tangent x. Sin y per cos y is tangent y, equals to p plus p tangent x tangent y. Now the next step is to compile tangent x on the left side. So tangent x minus p tangent x tangent y equals to p minus tangent y. And then if you see on the left side, we have tangent x minus p tangent x, which means we can factor out tangent x. Then in bracket, we have 1 minus p tangent y equals to p minus tangent y. And finally, tangent x is equals to p minus tangent y per 1 minus p tangent y. So your task is to do question 7.